All right, hello everyone and welcome. This is the OCP Tech Update. If you're not attending the Tech Update, you might want to check the sign outside. Don't want to bore you for the next 3 hours. My name is Archna Haylock. I'm with OCP. I am the Community Director for OCP. So a couple of house cleaning things before we get started. Number one, restrooms are outside on the right, so if you need them, just walk out the door and they're right there on the right-hand side. Secondly, a couple of thank yous. First to Booking.com for hosting this great event. So thank you very, very much. Chris, Lasser, Ryan, everybody here, thank you so much. And then what else? Anything else from housekeeping perspective?
Can we thank everybody for bringing equipment?
Oh yes, Circle B has got an amazing half rack here.
Delta, Cumulus.
Delta, Cumulus. It's full of OCP gear. If you get a chance, I know Bill's going to speak to it much later, but if you get a chance, please go check it out. And Minnow and Megan, thank you so much. I think there's a few people here from Delta as well. So thank you. Okay.
Thank all of our speakers that we ended up with a full agenda today.
Yeah, I mean, look at the speakers. You guys are going to learn something really great. Mark Dansie, Jean-Marie, Menno, Attila, Chris is right there, and Fareed is back there too. So thank you so much in advance. Okay.
Hey, 1 month from today.
Oh, 1 month from 1 month from today, we're having our summit in Europe. In California, March 20th and 21st. If you happen to be in town, please come and visit us there. We're expecting over 3,000 people. It's in San Jose this year. Last year it was in Santa Clara, so much bigger venue. I think we're going to have about 12 engineering tracks, about 150 so odd presentations between executive tracks, keynotes. So I think it's going to be just 2 days of great exchange, great collaboration, learning new things, exchanging great ideas. Okay.
That's it?
No, I've got a couple more slides.
Okay.
So, sorry. What do you call it? So, how many people here is their first time at Okay, wow. About half, I would say, right? Yeah. All right, for those of you that are new, have you heard of OCP before? All right, cool. All right. I'm just going to do a quick update on it, and then we can go from there. So, who are we? We're a nonprofit organization established by Facebook. Today, Rackspace Intel, today we're about 195 members. We're growing. We have over 140 contributions in our portfolio, 22 different companies, and if you go to the marketplace, you're going to start to see more and more products. Our marketplace is our channel, sales channel for those that are having OCP recognized and OCP accepted products, along with all of our specs that have been approved by the foundation. They're all there, so you can go, go up there and take a look. Who are we? So, pretty small organization. 3 of us are here. Bill Carter is our CTO. Steve Helby is our VP of Channels. And then I'm taking care of the community. We also have a Director of Marketing. And then some of you have heard of John LeBan, who's our European representative. And then we have an events manager and membership. So very small foundation, but you can see our foundation board is made up of Facebook, Goldman Sachs, Intel, Microsoft, Rackspace, and then we have Andy Bechtolsheim, the ex-founder of Sun, and I think he's the current founder of Arista. And then our incubation committee is our technical steering committee. So each one of our projects has a representative, and all of the products and specs get voted on by our incubation committee. Here are our projects. So we have 11 projects. 2 of them at the very bottom are fairly new, like within the last 3 weeks. So they're starting to build their own communities, and I will let Bill talk about each one of these projects and what's going on in each one of these projects. But each one of these projects do have online meetings that occur every month. There's wiki pages. There's mailing lists that you can subscribe to, and then they're all available in one place at our project's website. So please go online, please subscribe to the mailing list, please join a call or two, or join a community or two, and all of this is free, it's completely open, so you don't have to be a member, but you can go on and take a look. So I get asked two questions as the community director. Number one, how do we join? And number two, what do we contribute? How do we contribute? And how do we take advantage of the contributions? So I'm just gonna spend two slides on that. How to join, go to our website on how to join page. It's pretty self-explanatory. It'll tell you all the different membership levels if you wanna join as a corporate member or if you wanna join as an individual. How do you become a member, get involved, share your expertise. And then as you get more and more into the community and as you start learning and sharing with the community, then you can contribute. And the contributions are really coming in the form of, specs designs or white papers, case studies, testimonials, any kind of subject matter expertise that our community can benefit from. And then if you have a product that meets an OCP, an OCP spec, then you can also apply for our recognition program, and Bill will talk to that. How else can you get involved? Well, you can adopt OCP products. You can promote the OCP brand, and you can take an existing design, leverage it, and make it your own. And then hopefully share that expertise back into the community. How do you contribute? So we talked, you're probably familiar with the traditional, which is the specifications and the products, but we're also accepting configurations that have been tested using OCP products. So Cumulus is a great example. Backpack has been tested with OCP products, and that's something that we love to hear about. Reference architectures, software validations, client testimonials, white papers, case studies, any kind of things like that that the community can benefit from that you're using today. We absolutely would love to hear, and the community wants to hear from you. So that's another form of contribution. One last piece of clarification, OCP does not own any IP. We don't want your IP. We want you to share your ideas. So when you're making a contribution, you still retain your IP. All we're asking you to do is share it and don't sue anyone that uses it. So it is an open community, and so we don't retain any IP. With that, the call to action. Join a project or two or three. The more involved you get, the more you'll participate, the more you'll learn. We have project leadership positions open, so if you get involved in a community, you can also run as a volunteer leader. And those nominations are starting up in June. It's a 2-year term, and we would love for anyone that's in the project community to run and join. Contribute, and then apply. If you have an OCP product today that you're using, we would love to see that as part of our recognition program. And that's it. So with that, I'm going to turn it over to Bill, our Chief Technical Officer.
Boot up real quick and
Yeah.
switch.
Yep. Here.
I'm gonna use that.
Yes. You gotta use it so they can hear you.
There you go. Okay, I got 30 minutes. Actually, I got 24 minutes now to try to cover 10 different projects. So I'm going to go really quickly. I'm not going to cover all 10 of them. I'm going to cover some of the new ones. I'm just reporting out what goes on. These are community-driven projects. We have project leaders from the industry that run those projects. They meet on sometimes several times a week, sometimes once a week, sometimes once a month. Have monthly calls and use forums like this to get together. So I'm just going to go through a couple of them that with a lot of activity and a lot of interest. We have a networking project, probably one of our most active projects with over 600 people on the mailing list. At Summit, I think they have 3 different tracks in parallel just to handle the 40 or some odd presentations that are being submitted. We have open hardware designs for lathe and spine switches. They deliver anywhere from 1 to 100 gigabit Ethernet speeds. There's power over Ethernet options. There's wireless access point options, and even now campus-based wireless solutions that we're going to run at the summit this year. So we're going to run open hardware and an open software stack for our wireless support at the summit. And we have 5 or 6 different software projects that are underneath our networking group. The most widely known is the ONI installer, open network install environment. Every white box today uses ONI as its installer. It's an open source boot installer. We also have a switch abstraction interface API spec and development that's going on to basically abstract the network processor so that your network applications and stack can run on top and easily port to next generation network processors. So as network processors come out, you can easily make that transition as quickly as possible and stay ahead of the technology curve. We have an open network Linux that we support and make sure runs on all of our OCP boxes. We have a group that started Open BMC project, and it's actually pretty prevalent in the networking project. Open BMC is being used on most of those boxes today. We have an open optical monitoring project, again, open source software to monitor the telemetry information coming out of your optical transceiver. So information like speeds and feeds and heat and things is useful to try to avoid potential data center problems. And then control plane software, Sonic being the biggest one, probably 60 or 70 people every week call into that software development project. Pretty exciting there.
Could you speak up just a little bit?
Yeah, sorry. We have a server project, and again, probably the lion's share of our contributions come through the server project. We got compute nodes, probably 20 different types of compute nodes for 3 different architectures: the Open Rack architecture, the Olympus architecture I talked about, and then the standard EIA compatible. Olympus is a new architecture that Microsoft has worked on for the last couple of years. They're deploying that, began deployment this last year, and they have contributed all of the designs for that entire solution. And there's about 10 to 14 other companies that they've partnered with that are also open sourcing their designs. It's a rack level solution. It starts with a standard EIA 310 rack, so this is your standard 19-inch rack. It has a custom PDU on the back of it, and allows the server node to actually hot plug into this PDU. The beauty about the PDU is that it really interfaces with any type of data center. So Microsoft goes into hundreds of different colos around the world, and they needed to be able to plug in and attach any type of a power source. So they can support anywhere from single phase to 280 volt 3-phase input, both A and B feeds, and it brings it into a single rectifier into the system that does your A and B switching, does 3-phase conversion direct to DC, and so you end up with a perfectly phase balanced, resilient power unit into the server, all fed through a single cable that you attach into your data center, and intelligence built into this PDU. Servers are available that support Intel, AMD, NVIDIA, and Qualcomm processors today, and more under development. Pretty interesting design. It's really being rolled out now to the mass market and other adopters. Circle D brought one of the server nodes. I think it's a 2-socket Xeon. It's on the table. You could take a look at that at the break. We have a rack and power group. Originally, this was our open rack project. It's now expanded to include all rack and power options that are open source. Lots of work going on here. This group is kind of the keeper of our open rack 2.1 spec. They're working with a couple of different contributors and looking at ways to improve that spec. A couple of improvements on the horizon are, looking at the HPC demands and understanding how we can kind of consolidate those demands on some certain types of configurations. We're looking at feedback from some NEBS testing from Nokia and what we could do to bolster the design with some rack options. We have some proposal for standardized indicators that are being kicked around. We're looking at interoperability of the power shelf, and particularly between the rectifier and the battery backup unit, so that you can interchange between suppliers and be able to pull out a rectifier and insert let's say a lithium-ion battery pack and have it work seamlessly. There's also in the 2.1 spec, there's the option for a 48-volt bus bar, and so Google's come up with a couple different designs to run a 12-volt IT load in a 48-volt enabled rack, and they have a sled and a converter board that they've open sourced and actually made available for prototyping. There's some work to standardize some bus bars and some work to come up with a better cabling system. Power connectors options, again, all compatible with the 2.1 spec. This is just an example of some of the work that's going on. One of the challenges is that you can ship different types of bus bars in that. There's a 12-volt bus bar, a 48-volt bus bar, and then obviously you have to add more copper if you go to higher power densities. And one of the challenges is you ship out a rack and it may go to 2 or 3 different data centers with different power densities, and so we realize it's probably easier to kind of separate the bus bar from the rack itself, allow those to be independently ordered and shipped out and deployed separately. And so we're just making a few little features in here so that it's easy to, again, create a standardized bus bar, ship it out and deploy it based on the location that's going into and the customer. So that's underway. We also have a storage project. There's some storage products that have been open sourced and available, and you can go download the files. Lightning is one of those. It's a PCI direct expansion box. There's actually a sample of Lightning over here. You can pull that out. I think it's some really nice, it's really easy to use, really easy to service, and hot plug drives. There's a lot of work going on with storage and rewriting the APIs, and I don't know if you're familiar with the T10, T13 standards body, but I think the last time that they updated a standard was in 2014. So they're a little slow, and because of that, a lot of the folks that are involved in our committee said we can probably move faster by writing our own standards and try to get things to move quicker. And those standards are really around how hard drive and storage is used. So looking at ways to add features to the API. The first one was called fast fail read. In other words, when you execute a read command to a drive, if a drive responds, great, but if it doesn't, what does it do? It goes into retry, and then times out after 10 or 15 retries. How many milliseconds later or seconds later? It can be forever, right? Meanwhile, your app is waiting for that damn drive to come back. This is a really simple idea. Is that let me just issue a fast read command. If it doesn't come back immediately, I'm going to assume that it never executed, and I'll just move on to the next command. But it's a software programming option. Similar, there's improvements in the host interface. There's improvements with shingled media storage and SMR options to basically hybrid options for the media, and looking at ways to standardize and improve upon hard drive mounting and device and qualification. So all the work that's going on in storage group. We kicked off a couple of new projects in the last month. One is Open Systems Firmware. This project really builds upon some work that Jean restarted probably a year ago. We realized that we're an open hardware group, but hardware doesn't work unless it has software and firmware. So we're tackling the firmware aspects of open hardware, and this one's really to tackle the whole initialization and bootloader process, and do that in a way so that we deliver a web scale cloud-focused solution. The diagram on the right is the standard UEFI flow, and you can see it's quite complex. You go through, chipset initialization. These are a bunch of binaries that nobody ever gets sourced to, and we don't know what happens to that. Companies like AMI write a bunch of secret sauce and figure out how all these different initializations occur. They pass it off to UEFI. UEFI executes a few drivers, some in the neighborhood of about 150 of them that are loaded. By the way, those drivers, we don't know who wrote those either. They come from a lot of different companies that come in the source of a binary blob. Sometimes they're open source, sometimes they're not. I was looking at the make file from Jean-Marie's site actually this morning. I counted 146 different DXE drivers that have to load during that phase, none of which we have open source, know who wrote or know what they do. So again, a lot of opportunity there. And finally, move on into the actual boot process and boot stage loader. And unfortunately, there's things that are resident, that stay resident, and we don't necessarily want those things to stay resident because they create security holes. And so we want to really reduce the landscape and our security threat. And so, the boot process really is, loads up your EFI kernel and SMM kernel. We want to decide what we turn on and what we don't turn on in terms of these other processors that exist, the ME being one of those. But there's other processors that are active throughout the system, and we just need to understand what we're doing when we operate a secure cloud. So there's lots of opportunities. The first is to create a set of relocatable binaries during that PEI phase, or processor initialization. And we want to, recognizing not all of those will be able to be open source, we at least want to make sure that they're relocatable so that we can build BIOSes and at least have the open source code available to decide what we include in there, and more importantly, when we have processor bugs that we have to immediately fix, that we have a way to do that in-house without being reliant on external companies or external resources. And so relocatable drivers is a big part of that. And we also want to open source as much of the PEI code as we can. There's a lot of things that don't need to be open sourced. They just have been in the past. We also want to look at the whole UEFI execution and understand what we can do better. Again, that was code written 25 years ago in some cases. We're dealing with a lot of legacy. There's opportunities to speed up the boot process significantly by looking at that process. And finally, where there's opportunity is simply replace some of that UEFI and potentially use Linux boot as the boot manager. Rather than have to write, for example, an I2C driver or a Super IO driver, an SM driver, all of which exist in Linux, why don't we just use the driver that exists in the Linux kernel? We trust it. We have plenty of cycles of trust on that, and with that device, we have open source with that. Let's just use that instead of the embedded UEFI version. Doesn't work for everybody, but in some cloud cases it does work. And so that's again another opportunity to replace that. So big project, probably go on for years, lots of work ahead. Sorting out the licensing and then open sourcing of this will be a challenge, but we got a great group of folks working on that. We also kicked off another project to address security. You think about all the different security hacks that we've been hit with as an industry for the last 6 or 8 years. Great team of folks that are tackling this from Microsoft, Google, Facebook, and others. And they've identified 4 things that we want to initially work on. Want to come up with a better hardware root of trust, use that root of trust to do secure boot, and then look at attestation of all the mutable firmware. We also will probably, through that process, identify the common threats that we see, and then come up with solutions for those. And then drive those across, drive that security architecture back into all of our open compute devices. And so working across all the other projects. We have a pretty active hardware management group as well, and we're that group is really looking at adopting OpenBMC and making improvements to hardware management. The DTMF organization has published the redfish properties. I think it's about 100, somewhere between 120 and 150 properties in which you can pick and choose which ones you want to support. If you're a consumer of IT hardware, you have to guess which ones are supported on your IT hardware. We'd like to take the guesswork out of that. We're going to prescribe which ones that ought to be in the IT hardware. We're going to ask that all the open compute hardware support those. We'll call that the OCP profile, and we'll state which profiles, which properties are going to be required in our hardware. That way, regardless of where you get your hardware, it should be managed exactly the same across all the suppliers. We're going to leverage the interoperability test suite that comes from Redfish, and we'll roll that into our product recognition program. So that group is actively doing that. They've identified a hardware baseline profile across all the different hardware devices, and they're working on profiles specifically for server, storage, network, telco, and rack and power. So the idea is if you buy a storage device, it will be in the future, it'll expect to support a baseline profile plus storage specific Redfish profile. The idea is we'll be able to give the software community and all the folks writing orchestrators or implementing ONAP a target and says if you buy OCP hardware, it's going to be managed exactly the same way regardless of where it came from. I'm going to skip data center facilities. Mark Dansie is going to talk about that. And let's see, I got a couple more minutes. We also are working with some of the large software organizations and actually formalizing some affiliations, the first being Linux. We work pretty closely with the Linux Foundation, specifically the networking groups within Linux, and we're putting together more formalized plans. So the first being a plan with the OPNFV group. They actually operate about 20 different labs around the world in conjunction with supplier partners and ODMs, and we want to be the hardware of choice in those labs. We want open hardware to be the preferred hardware when they build out these solutions, the OPNFV solutions, and run those. We're actually working with OPNFV and the Linux Foundation on a virtual central office demo. They ran this last year in Beijing. We're going to run it at our summit, and we're working on the radio network aspects that will run on open hardware. I think we'll get to hear a little bit about some of that work that's going on Telefonica later on. Similar, we're working with the Cord group under ONF, and again, working with them to be the preferred hardware provider and making sure that we have the right hardware. So OLT devices, for virtual OLT, GPON devices, 10 gig GPON, CPE equipment. We want to have open hardware solutions that the telecom industry can use when they reconstruct the central office and the work is in Cord. And then obviously working with Facebook's Telecom Info project. We actually have a joint project there to do a CPE equipment for them. And we're doing the hardware. Our community's doing the hardware. They're doing the open software stack for that. So that's just some of the project work going on, kind of the highlights. I could spend lots of time talking about it, but I'm out. I got 2 more minutes. Last year we rolled out a recognition program, tried to make it really easy for consumers. We have 2 logos in place, one called OCP Accepted. Products that carry the OCP Accepted logo comply with 100% with an OCP Accepted specification, and the design files have been open sourced. You can also have a product that carries an OCP Inspired logo. That product will still meet the specification that's been accepted, but for one reason or another, the supplier has not actually open sourced that particular design. So think of it as like a second sourcing option. Still meets the specs, still interchangeable, but you may not be able to get the schematics, for example. We also have a OCP supplier, a solution provider network, and they carry a OCP solution provider logo. The one thing you can be assured is that any products that carry either one of these logos have demonstrated that they're efficient, open, they're impactful to cloud, and that they scale out with cloud. And our incubation committee and the 10 members that Archna introduced you to on the earlier slide, they make sure that these products meet those requirements. And finally, last year we rolled out our marketplace, and so all the products that carry those logos can be found on the marketplace. I think we started off with about a half a dozen. I think we're up to somewhere in the neighborhood about 80 on there, and it grows by a dozen or so every month. So that's where you go find out what's available in the marketplace. So anyway, thank you very much. I'll be around to answer questions. And who we have up next?
Mark.
Is it Mark?
Sign.
Great.
All right.
There you go.
Yes, we're going to need a 5 All right. Thank you.
Welcome here. My name is Stijn de Kruijf. Next to me, Mark Dansie. Next coming up is the presentation about the Colocation Facility Guidelines for open computer racks. We're presenting it with the two of us. Myself, I'm working with Roy Ascot GHV as an engineering company. Mark Dansie as owner as an Inflection. And the reason for presenting the two of us today is that we have are complementary. Myself, I'm looking from a design engineering perspective to Colocation Facility Guidelines, and Mark from deployments of fast deployments of big scale open compute racks. So that's we are very complementary to each other, and therefore we are with the two of us. I will do the first couple of slides, and then Mark takes over for the interactive part of the session. Let's go. Okay, some background. We will tell some about the background, the context where we are in. You already saw the 11 projects running with Open Compute. The objectives, what we are after, and then Mark will go into depth on the guidelines, what's happening in there, and we will end with some future thinking and next steps, because it's running on our projects together. So why the Colocation Facility Guidelines? Why was this developed? This is part of the data center project within Open Compute. Why was it developed? The original reason was that Open Compute was not unknown, and people who want to deploy Open Compute should be aware what the Colo facility needs as requirements to be able to deploy Open Compute. So that was the original reason, to get understanding what are the requirements, what data sets are we looking for. The context, we already heard about the 11 projects. This is 9. The new 2 ones are not here, but and the facility in the middle. So that's always with the facility. The facility is facilitating. So it's should be developed based on the requirements from the other stakeholders. So therefore, the facility is following what the different groups are developing, and then that should facilitate the open compute deployments. So the facility guidelines is a document, you can grab it, you have a checklist with it, and the objective is to have the fundamental requirements for the facility, and you can read it when you want to deploy Open Compute hardware, or you want to get Open Compute in your facility. You can read it and you check how you can obtain a pain-free deployment of the hardware, and that you are not surprised when the racks are already on your front door, that you should have checked it before. And so it's enabling pain-free deployments. And the group, the target group of this is the first in line is the data center operators and the tenants. So that's the short-term group. For myself, I'm looking more for. We are engineers of the data centers of 2020, so the concept for those data centers are also now at the drawing table, and the objective is also to implement the next generation data centers should have also enable those open compute deployments or likewise. So that's the future data centers should be prepared of the developments of this today, and the data centers today are designed 3 years ago. So practical, some practical points. What is Open Compute about for the rack? That's a good example. We have here the first line. We go for line by line, but the installations are served from the front. So they are. All services are open, and maintenance is done within the cold tower. A lot of data centers at the moment is cold tower containment. In the future, it may be turned around that the people are working on that the hot hour is contained and not the cold hour. So that's our principles which can influence the data center design. Also, the data cables are located in the front of the rack and not at the back of the rack. So, cable tray routes should be developed that enable the data to be entering the rack from the front. The racks are integrated directly in the containment. Also, practical-wise, if you build your containment, you can deploy. You put your racks on the spots, and then you have it contained already. So the data center, it should be good if the data center can enable already that fast deployment, providing the first part of the containment, and with the rack it's full contained. And another one, but that will be also one of Mark will go into, is the racks arrive at the front door already installed in a crate. So it's quite heavy. It doesn't need a lot of work to get it to the data floor, but you have to be aware that your routing from your loading dock to your white space enables this principle. I will now hand over to Mark to tell us something about the facility guidelines.
Okay, thank you, Stijn. Could I just get a sort of show of hands first, just to see who's actually seen the guidelines? Okay, excellent, that's great news. And for any co-location operators, has anyone used the checklist to audit their facility? Has anyone used it for that? Okay, and for tenants, has anyone used it to check facilities to see if they're acceptable? Excellent, okay, thank you very much. So just to describe the contents and structure, we split it into the 4 subsystem areas of the data center, the architectural and logistics aspects, the cooling systems, the electrical systems, and also the telecommunications cabling, which includes pathways, spaces, and network architecture. And as Stijn mentioned, within the checklist we've got, within the document, there's a link to a Google Sheets checklist for OCP racks, so you can easily get that downloaded and start using it. So I'm a technical project manager, and I try my best to avoid this situation when building out a data center. So having a checklist what I believe will happen, we'll try and avoid this happening as much as we can. I know this looks extreme, but I've come across situations where we've had racks turn up that have already been built out, but we've then had to take the kit out of the racks and then having to lean it over to get the racks in, then having to build it again, which completely flies against the whole principles of a smooth and quick deployment. So within the checklist, we've got some attributes and some parameters to help understand what you need to know about before bringing the open racks into place. Also within the guidelines and the checklist, we've looked at the delivery pathway from the loading dock and to the white space, and we've provided some guidance around where maybe the rolling load isn't sufficient for a rack to be put on casters and rolled through the corridors. Maybe sometimes you need to put in spreader plates, which will help get a fully loaded rack through the data center. And again, this is another thing that we've got to avoid embarrassing situations. I've come across situations where this hasn't been thought about when the lease has been signed. We start the project and then someone says, hey, what about the weight loading? Has anyone checked it? Oh yeah, the weight loading's been checked of the access floor, but the structure underneath is actually of a lower specification, so then you have to put structural steels in. So again, a little bit of thought, a little bit of understanding what the requirements are can smooth the path to a fast deployment. So the question is, are your architectural and logistics fit for purpose for bringing in open racks? And the guidelines and the checklist help you understand whether that's the case. Another subsystem that we've looked at is the cooling containment. Stijn was saying the majority of containment systems and the cooling in a data center is generally cold air containment and is acceptable. We don't want to exclude data centers from not being able to install open racks if they've got cold air containment, when taking the best of open racks and employing them in a hot air containment is the optimal way for technicians to be able to work in a comfortable environment for best cooling efficiency. Hot air containment we see as the optimal arrangement. So again, for tenants looking at facilities, can the colo provide hot air containment? And from a colocation operator's perspective, can we provide it? So these are the things that it's good to consider. Another system, a very important subsystem, the electrical main infrastructure. Many colos, probably the majority, all have centralized UPS. Now with open racks and having the ability to install battery backup units and power shelves in the racks, so the UPS is within the rack. That's a benefit, but say you can't get that non-centralized UPS supply, so then you have to use the UPS in the data center. So the optimal arrangement is not having a non-centralized UPS, where it's the ability for the rack to take over the backup of the power supply. So this is again something the colos to understand, can the electrical infrastructure be simplified if the customer would like to use battery backups in the open racks. And the last section, again, this is something where we've got a must-have really, where network connections have to be routed to the front of the rack. That's a given, it can't be avoided. That's how the open rack's designed. Something that just needs to be checked on. And just give an example here of how the space could be laid out within a pod. So just to quickly have a quick look at the checklist. Within the appendix, I've just blown up here one section of the checklist. The checklist has been split into two types. We've got a detailed checklist, which has got some advice built into it, where you can understand how we've come to the parameters that we've decided on. But we've also got a simple one that could be used for auditing purposes when checking whether a data center can accommodate an open rack. So as you can see here, the top line, we've got row here. We're looking at the data center access, and we're looking at the access routes from the loading dock to the goods in. And an acceptable would be road level, step, and threshold free access. But ideally, we have a loading dock with a lift or leveler, so the racks can be taken from the lorries straight into the facility. So the Colo Guidelines is certainly work in progress. We have a version 1, but we're also looking to other aspects as new designs come through. We're also considering other developments within OCP, and we need to understand those so that we can change the guidelines as necessary. Stijn, would you like to take over and have a look?
Yeah, so that's for today. After the sessions, you can come to us if you want to discuss, because I heard we have short of time, but interested for now is the discussion is what's next. The guidelines are not fixed, like Open Compute is always moving ahead, and that's showing by this picture. So everything is evolving, and also the facility facilitating those developments should evolve. And so the Open Compute benefits like energy efficiency, sustainability, less material used is also applicable for future data centers, and that should also be energy efficient and sustainable. So yeah, maybe the racks will ramp up in kilograms, that's impacting the data center directly, or maybe they will become immersed servers, or does the rack only has an end feed or not a dual feed? So those questions are interesting for the facility, because that are the cost savers also for the facility, and then you can have a lean facility just fit for Open Compute deployments, and that's I think the one of the goals for the facility designs. You take the rest? Yeah.
Should we just ask the audience here? We picked a specification of 500 kilograms weight loading for racks. So, have we picked the right weight? No, we've got some shake of the heads here. What would be a more appropriate minimum weight loading?
So we just received a rack with 30 trays in there. That's already 680 kilos. And the Hadoop racks, if we were to receive them a piece, which we don't yet, that's 1.5 tons because of all the hard disks in there. If you look at the storage devices that Open Compute specifies, and you actually load a rack with that, then that is also 1.5 to 2 tons. That is an unlikely build, but it is a possible and completely valid build. And if you write the specifications for data centers, they should take that into account. It is probably not possible to receive that in a data center with the raised floor. It is probably only possible in a facility with a concrete floor, but it is still a valid build. And you have to talk about that and what the requirements for that are.
Yeah, I mean, certainly I've been involved with some facilities where we could put structural steels to support the access floor, but yeah, most definitely a solid floor is the preferred route. But that's great. Thanks for that feedback. That's good to know. And we're going to have to discuss this to see about changing. Sorry.
When you move to immersed servers in the same floor, you basically could add about a ton on 500 kilos if you want to move to an inverse direction. It's just the unique benefit of that is that you don't need a raised floor whatsoever or on whole aisles. It will just work with only one. But yeah, you would need a lot more.
Okay. Thank you. So just quickly, we're running out of time, but one of the other developments one of another sub-projects we're looking to develop is a telco specific guidelines document. So that's certainly, it's on the cards. We're discussing this with the telco group, but I think that's something we feel that would be useful. Again, show of hands, anyone here thinks that a telco specific guidelines document would be useful? Yeah, just a couple. Okay, thank you. And within the slide pack, sure it will be shared at the end of the session of certainly the next few days. But got various links here to Open Compute, to the actual guidelines documents. So click on these, you can get straight to them. They're in Google Docs, Google Sheets, so you can download those and use them as you wish. And also please join the data center project mailing list and contribute, because yeah, that's what OCP is all about. So thank you very much for your time.
Any other questions for Mark and Stijn?
So while Jean-Marie is getting set up, this has been discussed profusely in our data center project group. So if you are using them, one of the things that Mark had mentioned is please provide feedback, because that's how we make the checklist better. And number two, join so that you can understand exactly what the next set of guidelines are, whether they're for the telco group or for a colo facility or something else. So with that, Jean-Marie.
Thank you. Good afternoon, everybody. So my name is Jean-Marie Verdun. I'm French, as you can hear. Sorry for the accent. Hopefully you will understand my English. I'm part of the OCP project as a community member for many years, probably more than 4 years right now. I just have a few questions for you guys in the room. So how many of you owns open rack systems? How many of you owns more than 10 open rack systems? Okay. We deployed last year about a little bit more than 1,000 open rack around the world. So my company is based in France. I'm not there to sell you any open rack. I'm just there to provide you feedbacks on what's going on and all the issues you might be facing between moving from a POC stage, which I consider when you own less than 10 racks, sorry about that, to a production stage where you are going to try to put in production a full data center room. So we made a few issues, and all the benefits you can see into the open rack infrastructures are seen as hassles by your colocation owner. So you must be aware about that. So the first time you will come up with your open rack to a new colocation space, you will be super proud about the new features and the benefits you can take from that, and the fact that you will be leveraging less power, better PUE, less energy requirements on air conditioning and all that stuff. So you have to keep in mind that most of the time the colocation owner never heard about Open Compute. for a reason that I still do not know, but even if they are part of the foundation as a member, so there is a lot of data center around the world, and even if the foundation is doing a great marketing campaign and communication, if you go inside Paris, in the middle of Paris, where Equinix or a few other American companies own data centers, they never have seen any open rack in their life. And when you come up for the first time with a rack without doors, without side panels, with an integrated power shelves, a server which doesn't have a front panel, and that is wired from the front and not the back, this is highly disturbing for the data center owner. And if you don't follow a little bit their process, you will be facing a lot of small issues or pain. So, and I'm just there to provide you some hints on how to accelerate the acceptance of the open rack within a couple of data centers. There is a first thing and a great news. A lot of people are thinking that open rack are 21 inches racks. And we are all thinking that they should be wider than standard racks. That's not true. They are exactly the same size, 600 millimeters. So you must know that. So don't be afraid about the fact that you are going to break a cold hail or whatever. You can stick an open rack into a standard row within a data center. You cannot imagine how many colocation space came back to us telling us, we cannot accept that rack, it's 21 inches, it's going to break our row. But they never looked at the real physical dimension of the racks, which are exactly the same than a standard IEA 19 inches from a physical perspective. So just be aware about that. If they came back to you telling you we cannot accept the rack because from a physical perspective it doesn't match, that's not true. You can tell them that's exactly same size, same depth, and it's a little bit less taller than traditional rack in some cases, depending on the model that you will be selecting. They need 2 power feed in some cases, but they can run on one. One of the issues with the power feed on open rack is that the feed is coming from the top of the rack. If you look at the PDU, it's not coming from the bottom. In most data centers in Europe, you have raised floor, and raised floor means that the power is coming from the ground. It's not coming from the ceiling. And most of the data center owner doesn't really like to have cables being routed from the top of the rack to the bottom of the rack. So you should be aware about that. And it does require us to rewire the PDUs. And I will give you some hints also on when to do that and why you must doing it. And try to do it not at the data center space. Roughly, what we say is that open rack are providing some features than traditional technology, but in a better way. So that's, be always positive when you go to your colocation space, because the guys in front of you is going to be negative about integrating new technology. So where does it hurt? I soon introduce all these things. So people cares about the look. I don't know why, because we are putting racks into spaces where nobody is supposed to go, except IT technicians. And geeks are not really known for their capability in art or whatever. Sorry about that. And this criteria is really hard to overcome in some cases. So people, data center owners like to have very beautiful data center room, because in some cases they are doing pre-sales activity with new customers, and when they go inside the room, they like to show something which is super clear. And if you have an open rack without side panels, doors, and wires going to the ceiling, this is considered not as being super clear. But who cares about that? So we are more caring about the energy efficiency of the infrastructure than anything else. So that's the main argument. As Mark mentioned, the weight of the racks is definitely an issue on raised floor installation. So you really need to take care about that. So we can have racks reaching up to 2 tons. So because you spoke about the hard drive infrastructures, but in some cases we have data centers who accept in the compute room the battery. So if you know the open compute infrastructures, we also have some battery racks, and the open rack V2 has integrated battery, and they weigh a lot. And so roughly, if you want to deploy the global infrastructures, just target at least 2 tons. So that's the key things. And especially if you are expecting to run with battery in the compute room. So everything is set up for 3 phases deployment. In some cases, we still have single phases data center room. So they are not the best one to deploy OpenRack right now because you need to rewire all the electrical dashboard. That's not a good idea. The power distribution from the top is not really good. And one of the main arguments we are always getting back is safety and compliance. So just be ready to bring your certificates of compliance, especially if you want to deploy in the US. Each time we deployed in the US, when we unpack the rack, and the data center owner sees the rack for the first time, they say, it's not UL or FCC compliant, because it's missing parts. Or I don't see on the wires or the plastic parts what kind of plastic it is. So just as a quick background, UL is fire protection. So you must have a UL V0 certificate with you. So if you purchase a rack from an ODM or from anybody else, please ask him to give you both certificates for the infrastructure, because especially in the US, they can prohibit you to bring the rack inside the room for safety protection. That's really key. So what is funny is that we never got that request in Europe. We got CE certificate, so that's fine, and we can bring also all the safety certificate in Europe, but we never got that request in European data center. And the best place to deploy OpenRack currently is in China. So we are setting up a massive Chinese data centers, and this is really the best place to deploy them. That's the easiest one. They are really looking at the power consumptions and the scale, and the scalability. They don't care about the other things. Even if we do care, because we don't want to kill anybody. But that's the key thing. Just to finish on in the US, there is a lot of places where there is earthquake, and that's not really the case in Europe. But if you go on West Coast, from Seattle to San Diego, so most of the data centers are going to request that you have earthquake protections or mechanisms to avoid that the racks flip during an earthquake. And most of the time you forget to implement that stuff, trust me. And especially on OpenRack, so that's a very specific part. They do exist, but bring them with you, otherwise the truck is coming back to you. So that's the key things. The last things, which is also US dependent, is about the wiring, so the PDUs and all these things. So if you have to change a PDU cable, if you do it on site for any reason, the guy at the data center is going to explain you that this is not state-of-the-art implementation. It has to be done at manufacturing. And you say, okay, my electrician technician is certified. He knows how to replace a 4 or 5 wireless cables just to extend it or shorten it. But they don't want to do that. They are convinced that when you change the PDU cables, the whole infrastructure is going back to certification, which is not true, trust me. Even if somebody is telling you that he's changing the PDU cable is going to rerun the FTC test, that's not true. So if you have to change anything on the system configuration in the colo space in the US, do it into your warehouse. Don't do it on site. It's not going to work. And this is going to give a bad perception of OCP gears, and that's something we would like to avoid. And I'm pretty sure that the rewiring of the PDU, by the way, is the same things with the traditional hardware. But as they are pre-wired for raised floor, there's no issue. And trust me, when you are getting power feed from the top of the PDU, you always have to adapt the length of the power cable. If you are in Europe, don't ship an OpenRack for the first time without one of your technicians, just to explain to the guy that everything will go smoothly. So we tried to make it a couple of times. Each time the racks came back to us. Because the guys open the box, and they do have a stupid checklist just to validate if the rack is in a good shape. And when he doesn't see the door, most of the time they say, the door are missing. And they are shipping back the rack to you, telling you there are missing parts. Okay, that's not missing parts, it's supposed to be done like that. So that's also why you need to have somebody on site with the truck when the truck is coming. Then there is a lot of debates about that missing doors, that missing panels, and how to set up call corridor and all that things. So we ended up to the conclusion that you have two options, especially for the first setup. So either you go brutal, and you deliver, you didn't inform the data center owner that you are going to deploy OpenRack. And you have the right to do that because they are compliant with CE, they are compliant with UL, they are compliant with SEC. So, and as long as you are compliant and you match the physical footprint of a traditional rack, there's no reason why they couldn't accept it. So you can go brutal and then inform and teaching to the guy, here is the hardware, as you can see, it works, it's not going to burn, that's efficient, and it's suitable for your data center room. Or you inform and you deliver. But if you choose the second options, you have to inform at least a month before the delivery, because it's taking time, and most of the time you have to have a showroom somewhere just to show the hardware before being delivered. And trust me, that's feedback that we can provide on any data center. So we deliver to Equinix, Tehe House, and many other data center owners. I think the easiest one has been Data4. I know they are both in the room, so but this has been the easiest one. And perhaps because we hide everything. So, but but the key things is really do not be afraid. So you can do it. And that picture is a new data center room at Data4 in Paris area. It's currently filling up, so it was for the new the inauguration that it was set up that way. So that data center room is running with concrete, with power distribution from the ceiling, and we got networking from the ceiling. So it's pretty close to what we are all dreaming about when we deploy OCP. So that's the key things. What is really key is that you need to believe into what you do. Because trust me, when you go to colocation, except if you are the biggest customer of the sites, which is simplifying a lot of things because people will tell you you are the best and you can deploy it. But if you are a small customer or if you are a new customer to the site, you really need to believe into what you do to overcome all the unpleasant remarks you are going to get. That's really key, and you must be aware about that. That's my last slide, nothing written. A lot of people are thinking that there's no OCP gear in the field. So I think there was about 1,000 racks into this warehouse that we own in the US. And this has been shipped in about 2 weeks. So we have a very high volume and run rate around OCP racks. The key thing is that most of our customers doesn't want that people know what kind of technology they are using. But we deployed these kind of racks in Europe, Western Europe, in Asia, mostly in China, and United States currently. This is where my small team is operating. And didn't mention that my team is about 12 people, so we cannot deploy everywhere around the world so easily. So that's the key point. So, as a conclusion, it is doable to deploy OpenRack. For sure, it's taking you need to believe into what you are going to do. If you don't believe into it, you are going to be stopped by a lot of people who are going to explain you how to do things differently. But if you really believe into the technology, you can do it, and this can be super efficient. And what we think the more and more is that you have to put in competition the colocation spaces. So some of them start to really accept OCP gears, which is really good news. So this was not the case a year ago. And probably because in some way, because we pushed really hard some gears into their data center room without them being able to really understand what was going on. So that's the right time to make it happen. Please be focused on people who doesn't use race floor. That's, to me, it's 80s technology or 90s technology. So we are in 2017. So why do we still need race floor? People will tell you that's for air conditioning, but why do we need air conditioning? So we have technologies for free cooling, and free cooling can work mostly everywhere in Europe. So even in southern France. So to me, base floor should be really standing in the past. So, and try to push people to go concrete floor and with sailing distribution. That's the best way to address your upcoming needs, especially with the storage solutions and battery and all that things. Thanks for your time, guys.
We have a little time for Q&A. Any questions for Jean-Marie?
That's great. Thanks. Thank you. Right. We're running a bit ahead of schedule. We'll have Minot, and then we'll take a quick break.
So, hello everyone. My name is Menno Kortekaas, technical person at Circle B, and yeah, welcome. Today I want to show you some tips and tricks when working with OCP servers. But first, something about Circle B. We believe that OCP is the next step in the evolution of the data center, so that's why we say it's revolutionary IT infrastructures. We base our 21-inch OCP building blocks on Facebook designs. So one of the building blocks is the rack, the power shelf. We have actually several options for power shelves. Storage units and server units. And then there's networking as well. We believe that it's the most efficient container for like CPUs that will be in a server module, and storage that will be in a storage container, or how you would call it. So we have all the samples there: compute, storage, power shelf, and a switch, all in a 21 OU open rack. And it's also wasting less energy than traditional solutions, and also reducing the use of virgin raw materials by recycling plastics. So now to the tips and tricks. This is kind of the traditional way of troubleshooting, and you have to carry this through a data center, or even in your house or anywhere you want to try OCP. You need kind of this whole thing. And the Facebook way of troubleshooting, I have a server here. Don't know if everyone can see it, but this is Tioga Pass. And this is the latest development. Thank you, Chris. So it's called Tioga Pass motherboard, and you can debug it with the debug header here. And this debug header is also on Knox storage, the Lightning storage. It's on Honey Badger and other microservers, and it's also on the switches. So a lot of devices you can troubleshoot using this small card. So that, thank you. The debug card, it has a 2-digit LED display that will display a postcode, code from when the computer starts. It comes from the BIOS. It also has a small reset button, and it has a USB connection that you can use to connect to the serial console, and also a switch that you can select the serial console of either the BMC or the server itself. So you have like an in-band and out-band console connection. So the server specification, everything is described in the documents published on the OCP website, and everyone can download them and look into them. So I'll use these specifications to explain what's going on. And the first thing is to troubleshoot server boot issue. And let's see if I can get my presentation, my video here. So I put in the debug card, and it's showing a code 008230. And it just keeps repeating that code, and yeah, the server is just not working. That's kind of the state that it's in. So what we then do is to identify the root cause. Oh, you can put it down if you want. Yeah, thanks. So to identify the root cause of this particular issue, we go to the document that I've shown before, and it says that the display sequence will be 00, dim location, major code, minor code with 1 second delay. And the dim location code table is in table 11. So we had a 008230, I believe, and 82 is one of the dim locations. And then we have a diagram showing the dim locations as they are on the motherboard. So that's that's at that time in my video. My video is on YouTube. Everyone can see it. But on this video, you will see that I replace or take out the dim, and then after that it's all running again. So there will be a new debug card that will be even cooler than this one. And that's using the USB port on the server, and it has a remapped one of the wires is remapped to the debug interface, and this debug card has an LCD display. So for other stuff to troubleshoot will be much easier with this new debug card. And then on the LCD display, you'll see some more information, and it can also tell you in writing, like it gives you already on the LCD display, it can give you information about what it's doing and what's wrong. It's kind of like how you troubleshoot a car. And yeah, some temperature reading, information about the version, software, etc. More of this will be presented at the summit. There's a lot of the newer devices can use this. So the Tioga Pass motherboard, Big Basin, Yosemite V2, all those devices can use this way of troubleshooting. Another thing that you can do with this specific motherboard is you can take out the flash module for the BMC or the BIOS. So if something goes wrong during flash, you can physically take out the flash chip and use your laptop with just a simple $30 device. You can burn your own chips and play around with it. You can also use out-of-band Yahoo Flash tool to flash BIOS, or the in-band SOC Flash tool. And there's also a command to copy like the secondary to primary BIOS if anything goes wrong. So here are some very useful raw commands that are also listed in the specification from Facebook on the OCP website. One of them is to reset the BMC settings to default. Like, you need to know your password, but some other setting that you want to reset to default, there's a raw code for that. To change the priority of the network card from the onboard NIC to the mezzanine NIC. If you want to access the BMC through the mezzanine card, you can swap that. You can also power cycle a complete machine without like physically going there, pulling the plug. You can send a raw command and it power cycles everything, the out-of-band BMC and the server itself. You can change boot order as well, so if you want the next time to boot from Pixie, then you can change that with a raw command that's listed in the documentation. If you want to be able to use these features, then you have to look at before you buy a server, look at like that it follows the Facebook specification, and we work with WeWin. So all these servers that you see here, also the Microsoft server, they're all from WeWin, and they follow this specification. So then you'll be able to use the debug header, the raw commands, and the new debug card as well. What's next? If you want to see more gear, we'll be at CloudFest, and we'll also be at the OCP Summit in San Jose. We have a website, Twitter account, and a YouTube channel where you can see that video, for example, that I just showed a piece of. Yeah, hope you have nice traveling. Any questions?
Right. We're ready for a short break.
Yeah.
Yeah, about 10 minutes.
Yeah, if we can all get back here, start up again at 3:30, that would be fantastic. During the break, I encourage you guys to take a look at the gear. Any questions you have,
All right, folks, let me introduce you to Attila. He's here to talk about open networking and how OCP works with open networking. He's from Cumulus Networks.
So good afternoon, I'm Attila. I work for Cumulus Networks, and I'm going to tell you something about open networking and OCP. Since our presentation time got shortened a bit, I'm going to hurry, and I'm going to give you a demo, and that all in 10 minutes. So who is already familiar with the open networking concept? Okay, that's good, then I still have a lot to tell. So the idea is with open networking that you take commodity hardware, which is also available for switching in your data center. You install an operating system on top of that, preferably Cumulus, and make sure that you have the same advantages as web-scale networkers have by integrating it with all your applications and your provisioning and etc. That way you can take advantage of both the CapEx and the operational cost for your infrastructure. Now a bit about the hardware. So there are only 6 ODMs in the world who actually make network hardware. So it doesn't really matter where you order your hardware. It could be from Juniper, Arista, Cisco, but they mainly let those 6 ODMs actually make the hardware. A lot of that hardware is based on reference chipsets. Most of them based on Broadcom chipsets, and that ranges from 1 gig to 100 gig, and in the future faster as well. Now, if you then look at white boxes, those are usually produced by subsidiaries of the ODMs themselves. So you have the Acton Group subsidiary has that's the EdgeCore, but also DNI, and they produce the ECMAS switches. But if you want to have support contracts and more than just white box, then you can go to a supplier like Dell or HP. But either way, it's still based on the same reference design with hardware. And mostly the Broadcom chipset, or we also support the Mellanox Spectrum chipset. Now, if you look closely at the white box switch here, then you see it's a 1U model. And if you are building a network with 1U switches, then you do have some limitations. I'm assuming that everyone is familiar with the spine leaf setup, so you are building pods with spine leaves. But if you have more than 16 racks and each rack has 2 switches, then you have the limitation that most spine switches have 32 ports. So what you need to do is you need to build an additional layer on top. Usually you don't want to have any oversubscription in that additional layer, so that requires a lot of cabling and optics if you need that as well. Now Facebook has changed that because if you look at this, you can actually imagine a chassis. Because if you look closely, then you see fabric cards or a backplane, and you see line cards on the front. Now, that is exactly what Facebook did. They made a reference design called the Facebook Backpack, and that's contributed to the OCP, and it runs Cumulus, of course. So what you see here is a chassis, a modular chassis with 128 100 boards. But it's actually multiple switches inside that single box. So if you look on the right here, you see a line card, and you see the two cooling units where the ASICs are. So each line card has two Tomahawk ASICs, 100 gig, and they provide 32 100 gig ports to the front, and the same amount of bandwidth to the fabric cards that are in the back. And that physically all connects to each other, so you can completely disassemble the switch, and you'll be remained with an empty chassis or an empty shell. And that was actually what we were doing when I took these pictures. Now, the EdgeCore group, or Acton, they have an EdgeCore model as well that has 256 100 gig ports. So if you want to scale larger, then you can have a look at that as well. Now, what is also being done in open hardware is another design that Facebook made, which is the Facebook Voyager. The Facebook Voyager is actually a white box packet optical transponder. And that's based on the Facebook Wedge, which is a 32 port 100 gig switch. But in this case, what you see that there are only 12 ports on the left. And on the right side, you see 4 optical ports. And they can provide each 200 gig DWDM signal. And that goes through 2 DSPs that are being built in. So that means that you are combining both your optical network and your switching network for your data center interconnectivity. Now, one thing in OCP is important. How do you actually install an operating system on top of a box? Now, when J.R. Rivers, one of our founders, started, there wasn't any model to actually install an operating system. So one of the things that Cumulus contributed is ONI, the Open Network Install Environment. And the idea is that it's sort of PXE, but it runs on top of switches. And the idea is that you want to install a switch without even touching it. So I saw Menno had a nice display with a monitor and a keyboard, and that is something that you don't want to do if you have to install a lot of switches. What you basically do is you boot up the switch, and you use DHCP to get an IP address of your management server and automatically install the OS. And that's quite easy, so that means that you don't actually have to touch it. And the second time that it boots, it will boot the operating system after the installation. Now, in case of Cumulus, but if you run another OS, they might have something similar. We have zero-touch provisioning. And with zero-touch provisioning, you can load a custom script, and you can do your basic initialization. So if you want to use an automation tool like Ansible, you can provision it with your SSH key, for example, or Puppet, and install the Puppet agent. Now then have a look at how our operating system looks like. This is the architecture. And we are a fork of Debian Chassis. That means that you have normal Linux access on your switch. But running a Linux kernel on a switch isn't really that special. If you look at an XOS or Arista, Juniper with a BSD kernel, but they run all an open kernel there. But they don't actually use the network features in there. And that is what we do different. As you know, the Linux kernel already has network features such as IP forwarding, VLANs, VXLAN tunnels, ARP, etc. And we have added a switching daemon. That switching daemon looks at the netlink messages between the applications and the kernel, and it will program the ASIC in the hardware. So you have hardware forwarding. That means that none of the packets who are forwarded even come up to the control plane. That is being handled in hardware, so you don't even see that. Now, if you look at the routing stack, if you are building a spine leaf network, you are going to route and eventually build an overlay network on top of that. We use the free range routing suite, and that started as Quagga, but it was forked last year and is now free range routing. And what it does, it handles BGP, OSPF, all the protocols that you would need for that. But it's all modular, so that means that if you really don't like free range routing, you could install another routing suite such as BERT, ExaBGP, etc. Obviously, as Cumulus, we can't support every package that you install, so for BGP support, you're on your own there, but you do have the possibility to do so. Now, automation is quite key with data center deployments these days. You don't actually want to touch your switches or do manual configuration box by box. Since we are a standard Linux operating system, you can use all the automation tools that are already out there. So if you are using Puppet, you can install Puppet agents. If you are using Ansible, you can use that as well. The important thing here is that you are not relying on Cumulus for providing any modules for that. Because we have seen that a lot of people were switching from Puppet to Ansible, and Ansible is quite popular for networking these days. But what if there is a new tool next year? You can just still use that. For example, we see that a lot of some customers are moving to SaltStack because they like that model as well. And you can just use that on Cumulus too. Now, same thing for monitoring. Most people that use Cumulus, they see it as a box with Linux, and that happens to have 48 ports. So if you want to monitor it and manage your system, you can use SNMP if you want to, but SNMP is quite old, so you can also use other tools like Prometheus or install Telegraph and export data to an Influx database if you'd like to. Now, I'd like to give you a demo, and I did test it, but let's see how that all works out. Now, one of the things that is important of software and hardware disaggregation is that you are not depending on software, not depending on hardware. So that means that you have a lot of possibilities that you couldn't do before. And one of the things is doing CI/CD in your network as well. If you don't know what it is, that is a separate presentation, but then you have to come to our meetup on Thursday. But suffice it to say is, if you previously wanted to test a change that you are going to make on your network, you needed to have a test setup. And you can imagine that if you have quite a large setup, then you need to have quite a large lab. So one of the things that we did is we have a VM available. And with that VM, you can build a complete virtual network, test it as you would use a normal network. Obviously, you don't have hardware forwarding, but it does mean that you can test all the configurations, see what it does. Now, what I've done here is I'm using GitLab, and as you can see, there are two environments registered, or two runners registered to this project. One is a staging environment, and the other is a production environment. Now, what I'm going to do now is I'm going to make a change in my infrastructure as code. So I have some configuration here. This is just a static configuration, but people who know Ansible know that you can change it all to variables. So what I'm going to do is, for this specific port, I'm going to change the VLAN. So a quite simple change. And the idea is that as soon as I commit it into my Git repository, it will automatically start testing in a testing environment and do automated tests before I even push it to production. So what you're seeing here, I'm pushing it to production, If you like to, you can also do this through a GUI, of course. But a lot of our customers like doing something like this in a CLI. So right now I did the push, and I hope that it will show up in one of the pipelines. So right now you see that this pipeline is running, and a pipeline with CI/CD means that you have a standard template, how everything is being handled. So what you are doing from step 1, step 2, before you're pushing it to production. So if I'm having a look at how that works, you see that it's now being deployed in the staging environment, and that afterwards I would have the possibility to push it to production. You can also automate that. You can say, I want to push it to production each 4 hours, but that means that you need to have a lot of confidence in all your testing tools before doing that. But another advantage is that security-minded people really like this, because then a network engineer can prepare a configuration, and before pushing it to production, they can check the changes and see if that's still compliant to their security standards. So what you're seeing now here is I have an empty virtual environment. And you see that it's going to deploy an EVPN configuration in that empty configuration. Unfortunately, it failed. I don't know why, though. But, let me show you a previous job so I can show you what it's supposed to do. So what it did here, and what it was supposed to do, is that it deploys an Ansible playbook, and that means that I have an exact copy of the configuration of my production environment. And I have that same spine leaf topology, and you can build them as large as you'd like to. A colleague of mine built one with 180 switches last week. So if you want to virtualize a complete data center or make a copy of the production environment, you can do that as well. So what you're seeing here is that the Ansible playbook completed, and in this case it completed correctly. And afterwards what I'm doing is I'm doing a few netqueue commands. Netqueue is separate software that we use for telemetry and monitoring. And you can do quick checks to see if your entire fabric is behaving as expected. So one of the things that I'm doing here is a netqueue check EVPN. And what you're seeing here is that on all the nodes it's all fine, and it is working as expected. So that is one of the ways that you can do quick checks in a fully automated environment. Now let me log in quickly to the production environment. I called it production, but also that production environment is just a bunch of VMs. So I can show you how that looks like. Now, I'm logging into the virtual environment, and for people who know what I'm doing, I'm using a tool called Vagrant, and Vagrant allows you to define an entire topology of multiple VMs. So if I'm logging into a VM right now, this is basically how Cumulus looks after an install. So you have direct access to Bash, and you can edit your configuration files and make changes through them. If you have a background in classical network vendors, then that might be a step too far. So what we also added is a CLI. So you can use a CLI, and you have tab completion, so you can make changes on the fly on your network. So if I'm editing a port here, then I can commit this change to a configuration. Now, I already made this change to demo something last week. But say that I would have made this change to an MTU. And how long would it take for someone to debug this on a single interface with a different MTU size? Well, usually you have to go box by box to troubleshoot everything in your network. Because you don't know who by accident made that change. So, as I said, we have some simple check commands that you can do. And in this case, we have a netqueue check MTU, where you can directly see what the mismatches are on MTU sizes. So if you want to debug something like this quite fast, then you can do that. Now basically, that is what I wanted to show today. So if you want to know more about the open networking part in OCP, feel free to come to me. If you have any questions afterwards, I'll be sharing the slides anyway, but feel free to email me as well. And if there are any questions, then I'd be happy to answer them as well.
On the OCP Marketplace, they have a whole list of their OCP certified hardware that these guys run on top of, as well as on the Cumulus website, you'll see a compatibility list. All of the open switches that these guys run on are listed there as well. Thanks. That's better.
Yeah. My name is Christian Köntop. I have worked for Booking since 2006 or so in various ways and roles. I'm going to talk about Booking and still confused. That's better. We have been a small travel agency from Amsterdam once that ran a little website that sold hotel rooms that grew a bit over the years. Actually for, well, almost 15 years or longer now, faster than Moore's Law. So we end up today being about 15% the size of Google financially. We have some, not quite 200 offices in 70 countries. We run the site in 46 languages. And we offer travel basically to every part of the world that is reachable and interesting for tourism somehow. That's what it looks like. We sell hotel rooms globally. We are part of the Priceline group of companies. That means that Priceline also sells flights, rental cars, sells rental cars, and OpenTable offers restaurant visits. If you integrate all of this more, then we are basically offering everything that is necessary to have a nice vacation or a nice experience in general. So it's kind of moving from hotel rooms to something more trip-shaped and a complete experience. We currently run 3 data centers. These are actually not our data centers. This is rented colo space. It's traditional colo space, so it's Uptime Institute Tier 3 stuff that is available on the market. In that there is some 30K machines, so there we are only about 1% the size of Google, and all of that in way too many configurations. The hardware is mostly HP, Dell, Supermicro, 2-die, E5, Xeon type stuff. mostly 2620s and 2690s, strangely, because of some of the software that we run that is very dependent on single-threaded high clock performance. We hope to get rid of that sometime, but for the moment we are basically on the both extreme ends of the CPU spectrum that is available from Intel. We are a Rapstars-B company, that is, we mostly, for money, replace variables and HTML templates. That is a quite boring thing to do. The data that goes into the variables that go into the templates, that comes from databases. That is also very traditional. We have a pretty large MySQL deployment. We try to keep stuff in memory where possible, so if we see a disk read and anything customer-facing, there's probably a bug. It's certainly a problem. We run much more complicated stuff in the background, so we do the usual big data stuff. We have a very limited GPU deployment at the moment that does deep learning, image processing, and fraud detection, and experimental user interfaces, stuff like that. And we have a pretty large-scale data movement infrastructure for MySQL, for Elasticsearch, Cassandra, Hadoop. So all in all, it's not too weird. It's a bit specialized in what we do and how we do it, but it's all, where we have the source to everything really that earns us money. There is a SAP somewhere, there's a bit Windows in the Office area, but the stuff that earns us money, we can read the source to everything, and we also have the people that understand that and that can debug that. That doesn't mean that we want to change it. We are very much a hotel company and we want to stay that. But sometimes size or problems forces us to actually read that and then talk with the vendors about possible changes and what we need changes and what would be the best way to get that change into everything. So it's all very user-centric actually. We want to stay a hotel company, but size forces us to deal with more of the technology and to get closer to the actual hardware in order to manage that. Growth, we have been growing faster than Moore's Law for a long time. Growth looks like this. Because there are numbers here on the y-axis, I can only show old data, I cannot show recent data, but the shape overall is pretty much the same. These are room nights and hotels available on the source. These are also public numbers in the reports. But the curves for everything else, for machine capacity consumed, for meals served in the canteen, for people hired, for anything really, they look pretty much like that. And they look even more interesting if you put this on a logarithmic y scale, because then they become nice lines, and you can see then where that goes. If you translate that into data center capacity, we have a problem, because if you see this is contracted power, that is the actual power draw in one data center, and then if you add capacity here, you can see how that quickly escalates. If you naively draw that line further out, by 2040 we have covered the entire planet in computonium. That is a bit of a problem because we also need room for the hotels. But that is not going to happen anyway. It underlines the problem though. We need a change in the way we handle stuff, because if we add capacity like this, this is not going to work anymore. And this has very, very practical implications. Currently, we do a very enterprisey traditional build out. We get space, we do the electrical build out, we add racks, we add switches, we add chassis to the racks, and then we put blades in there. And we need to scale that out better. This is happening in waves, because all of these things have different latency from the time you commit to this actually being finished and useful. And because all of these things happen independently and in waves, they are hard to synchronize, they often go wrong, and then everything is bad and everybody hates infrastructure. Once the hardware is in place, we can then finally automate that, and for that we have a system called ServerDB. I will show a bit more of that later, which basically gives you an API and a web clicky interface where you can get one server or 200 and tell these servers to, for example, become a MySQL database replication chain, and then you will get a mail 20 minutes or 2 hours later that everything is finished and in production. That is actually nice. This way of doing things is pretty attractive, at least to people with a Netherlands background, because it allows you to delay large CapEx expenses as long as possible. So it gives you a lot of flexibility in spending planning and actually delaying the actual stuff happening. And with the business with that amount of volatility and growth, it is useful to make a lot of plans with a lot of variables and then commit to them only as late as possible. Commercial data center space, Uptime Institute Tier 3 space, comes with a lot of limitations. If you talk to providers of such space, we end up with a lot of small rooms that then give you a lot of placement constraints. We have a power limit per rack of 7 kilowatt, and this, for example, is a blade center here. If I kick that very hard, it consumes 6,400 watts. So if I don't want to overcommit to power or cooling, I end up with knee-high racks. That is a bit ridiculous. You have problems with build times if you build like this. You actually have trash issues if these things come in individual components, or maybe even the blades individually, and you unpack that in the shared space, the loading and staging area of the data center, then everybody else in the data center is going to hate you quite a lot, because if you get a monthly delivery, that means that for a week that ramp is completely unusable. And the interface we talk to the machinery to get it running is basically the LOM, whatever the vendor is calling it. And if the LOM is in any way different or not reliable or slow, we get a lot of hate from everybody because the machines are not coming up properly. Yeah, that's a load test for such 2690 in this case. I have been measuring the power consumption over the number of cores that I keep busy. And if you look at the total power draw here and multiply that with 16, then you end up with a 6.4 kilowatt chassis and a 7 kilowatt rack, and then it's game over. And that is a rack of 40 machines. I got 32 because I had 8 LOM failures during provisioning. These are Hadoop machines, they are 40 core boxes, and I get this 7 kilowatt rack running at 15 kilowatt here, so that is a huge overcommitment into hotspot, and that required additional cooling in this case. Yeah, I have, because the LOM is the thing I use to talk to the box, it's our gateway to automation. We are looking at LOM issues a lot. It's often underdocumented, multiple access paths. Which is a problem with auditing if you're trying to document a configuration. Make sure that what you configured in your system is actually what is running. That's really complicated. It's often insecure. It often uses outdated crypto, by default sometimes none. It has insecure client requirements. Some things require a Java console if it's older. That requires a Java version that I'm not allowed to run on this box because then corporate security is going to hate me. There are different access methods depending on the vendor. There is a partial fix for that. That is Redfix, which is Redfish, which is actually an open compute thing, or being used there quite a lot. There are differences in feature sets, which is less a problem because we are not going to use much functionality from it. We basically use power reset and boot preference, and optionally we're using firmware update and partitioning and controller config facilities, but there are other ways of working around that. As long as there's a command line tool, I can always boot into a RAM disk and then run scripts from the RAM disk to exercise the machine from the inside. So if a simpler, more reliable LOM means I have to do it this way, that is also accessible. And metrics, I use power, temperature, and cooling, and fault sensors. So it's also not a lot, and it's all read-only mostly. So as long as I can power cycle the machine and set the boot preference, I have only read-only controls necessary in the LOM. A simpler LOM that can do less, and that when it does something always interrupts production, is something that is easily audited. And that is something that the corporate security people are going to like a lot as well. So that is useful. That is ServerDB. ServerDB is ugly, but very functional. It's a thing that allows me to view everything we have discovered about the server with the various discovery methods. It gives me an action menu that allows me to do things with the server. It links to the monitoring, to the network provisioning, and the other interfaces we have. So it's very deeply integrated with all the other tools that we have. It shows me the toilet paper roll for the base system metrics. It used to be a single Python app, but that became unwieldy, so it's being refactored very hard now. and it is now mutating into a complex of systems doing network, switch, storage stuff, rack and machine configuration, and it leverages existing tools wherever possible. So a foreman can do a thing, we are not going to keep up our own code for the same purpose, but throwing that away and are integrating external projects into this. This allows us to get rid of a lot of infrastructure management and share the cost of maintaining all that with others. It has a lot of business knowledge, how are we doing things at Booking, and it does full lifecycle management for a server. So everything from actually interfacing with the purchase order system on the front end to getting stuff and decommissioned and out of the data center after several years is managed by this. This is the network view, it's called Memo, which is the network manager side of ServerDB if you so wish. It also provides rack views, multi-rack views here, single rack views in this case, also switch metrics, power consumption metrics and other stuff. And it does that across the entire infrastructure, several data centers and 10,000s of servers. So it also scales nicely. It's not limited to a single chassis or a single rack. That is where we're coming from, and if you're looking at where we're going to be at the current growth rate, it's pretty clear that what we need to do is we need to go rack scale, so we are not receiving individual chassis or systems anymore. We need to bring the volume up by having fewer configurations that allow greater production runs at the order side to get more favorable conditions there, and of course getting rooms to match the racks that we order. And that actually turned out to be the most important thing, and I'm going to talk about that quite a bit more. But first, let's look at the rack scale thingy. There is actually a way to order blade centers by chassis that actually reduces the trash quite a lot already. It streamlines the late provisioning phase. You get things quicker and pre-assemble. It's helping quite a lot. You're a bit limited in what goes into a chassis, and the chassis we're currently using is going to be discontinued. The reasons for that are legit and pretty okay, but the direction it's going in is not actually what we want. We see the same thing when we look at rack scale systems and if you look at inter-rack scale designs. You can order stuff also by the rack, and then you look at this inter-rack scale design stuff. HP, Dell, Supermicro, they all have their own variation of that, so they take what Intel has in the RSD definition and then value out their own stuff on top of that. That gives you a bit more design flexibility than blade center chassis give you. Depending on the actual physical design, it gives you the same shared power and cooling savings that chassis give you, even at a somewhat larger scale, but it's all pretty weird and proprietary stuff. It has integrated rack management. It comes with pod and rack level controller software, like a blade center chassis has a controller. It does, and that's a thing, a lot of composable hardware. So you have PCI switches that allow you to route disks to memory modules, but it does this with PCI buses that basically extend through a chassis or an entire rack. And that means that you have like a second rack scale network topology next to your IP topology that you already have anyway, but it's pretty limited in size and range that you have. And sometimes, if you look at stuff that Dave, for example, promotes, you can get this stuff with a data center wrapped around it. That goes into a weird direction though, because it is looking at shipping container sized thingies that are being used as building blocks. So you are looking at stuff that is built for very high density. You basically have to cram what you want into Legos of 8 by 8 by 40 foot. And then you look at very high wattages inside the rack, and that gives you constraints, again, in what you can do. It's pretty nice, but it is also a direction that we don't want. We want actually keep the density at the watts per rack at a moderate level, higher than we currently have, but if you go to extremes there, you are looking at expenses and at engineering challenges that do not actually contribute to what we want. So this is even more bespoke, and if you look at Open Compute, that is like well, shipping crates of computers, but ugly. But you only get what you actually need. It's like a JBOD of computers. instead of getting a RAID or other integrated system. And the value is then added at higher level software. For the management side, we have that. We have the ServerDB effort, which is going to interface with that. And for the production side, if you want at the workloads running at the machines and want them to be mobile as well, you're looking pretty hard at containers. And that means that you probably also want Kubernetes to slice and dice the machines. They're too big for most application workloads anyway, even the small ones. And you probably don't want to tie your workloads to a single specific bare metal machine anymore. You want it to be able to float around. And that has two requirements. One is the Kubernetes stuff, and the other is the storage disaggregation stuff. So what you get from Open Compute is a clean bare server design without any value add, and that's actually the value add because it makes the hardware extremely even. And the hardware that is there is documented, so we can integrate it with our own systems. We can actually look into the BMC if it's not working and see why it's not working or what it expects us to do. And because we can read and write source code, that is, we have potentially a lot fewer problems actually as well. The deliveries by the rack, that is a challenge that we just mastered for the first time. That was 680, 670 kilos approximately coming in. And in a traditional colo where we are, that is actually also borderline of what is possible. So we're probably not going to get Hadoop hardware by the rack because it will, on the way to the final location, break to the floor somewhere, even with spreader plates. That is not possible. 1.5 tons a piece is not going to happen in that location. Which also means we need to look at locations very hard. And these locations look probably a lot more like we heard in the previous talk here, with concrete floors, no raised floors, everything is flat and even, and then rolling equipment racks into place with no problems. Open Compute comes with a lot of potential operative and capital savings, but in order to unlock those, you actually need to be in a location that allows you to do that. And I'm going to talk about that a bit more as well. But well, getting volume up. This is the provisioning screen of ServerDB. In a location, you have a bunch of server profiles. This is actually, I've counted them, that goes to 11 here. 9 blade types at the moment, and blade 2A, blade 2B, and blade 2 makes it 11. If you look at those, they are basically 2 CPU and 2 memory sizes. So I might be able to get that down to 4. But there's a lot of variation in the storage that differentiates these units. There are often 2 disks or 2 SSDs. We actually want our customers to not rely on that. We want the individual computers to fail, not often, but they should have the very real possibility of failure, so that the consumers build systems that they can reproduce and that can fail over, that forces them to consider that and build systems that run without a single point of failure. I'm looking at the current ServerDB statistics, and there are about 500 machines that are pre-Xeon E5s. So they are X and L Xeons. That means they are from 2012 or earlier, and they have either not been provisioned or deprovisioned, or the ServerDB has invalid data. But out of the 500 machines, there are slightly over 100 that are labeled in live state. That means they are also in the monitoring automatically. So they're probably productive, and they can't even mitigate meltdown. They have no PCIe, CPU features, and other things. These things need to die, that is hard. They are hard to kill. I mean, if something is running since 2012, even if Puppet is on the box, then nobody knows if that puppetry is actually still going to work with current versions of things. So we need to exercise all that, not too often, but regularly, and keep everything agile, because otherwise we're building up a lot of craft, and then later constraints that prevent us from changing and developing everything. So having the possibility of things going away and failing is actually not a bad thing. It forces people to stay agile and still live with the possibility of change. That is useful. The answer is obvious: ban everything. In this case, we ban local storage. So we build machines with very limited local storage, probably not rated. SSDs don't fail that often anyway, so that's a good thing. We put up a per rack budget of 2 head units 500 watts and a single 100 gig port on the top of rack switch, and then give that to our storage guys and tell them put something in there, we don't care what, and make it available with iSCSI or NVMe over UDP, Rocky, or other things. These things will interface with each other, build redundancy across the racks, and all the compute will talk to that storage in some way. So we have east-west data access traffic, we have replication traffic, and that all happens on the iPad network, not on some proprietary backend network. We still have machines with fiber channel cards, they all need to die. I'm certainly not building PCI networking next to IP networking here. I'm using my IP network as the transport network for storage as well. IP cables, fiber cables, they are my disk cables now. And I'm telling the network guys to build a leaf and spine infrastructure that actually can carry that without dying. And that can be built out incrementally so that I don't have to spend all of that up front. That gives me pretty uniform production compute here and no local persistence. If you want to keep your data, you put it here. And that takes care of the replication if you want it, or you order storage here as JBots and then do that. If you're Cassandra, you're doing it yourself. If you're doing a MySQL, you're asking this to provide resiliency. But that also gives me workloads here that can migrate from one box to another, because they talk to iSCSI anyway, and probably not to local iSCSI, but somewhere else. So that will work nicely as well. And if I add Kubernetes here, that gives me resiliency, application mobility, and also capacity size adjustment to what the application needs and not what the hardware provides. And in the end, hopefully, if I can get rid of my workload that requires the 2690 CPUs, I can run everything on the very cheap 2620s or silver 41110s and be fine with that. And then I order only one type of rack and be done with it. That day, I will have basically optimized myself out of job, and that is my goal. So 4 profiles or less, disk as requested, location independence, independent hardware upgrade cycles, storage, compute, rack, it all can be upgraded independently. And because I have application mobility, I don't even have to interrupt production when I'm taking out the rack for upgrade. And I have one single network, aggregated 10 gig, 25 gig, or 100 gig. That depends a bit on the data center and the age of the racks to bind all of that together. The only thing that falls a bit out is the Hadoop environment, which is a bit special. But on the other hand, Hadoop is not built for latency, it's built for bandwidth and capacity. So I can actually optimize that even harsher. And in the end, it will kind of fall into the same schema, only if the details look a bit different. That's why it's a separate environment. Getting rooms to match. You have seen these images already. This is a classical Tier 3 Uptime Institute data center. This is an open compute optimized data center. These things supposedly can be built much cheaper. We ask and typically are being told for a megabyte of capacity, you are going to spend 10 million for an empty data center shell here. Facebook claims to be able to build this as a shed basically for 2.5 million. If I can get that for 5 million or less, I will be pretty happy with the outcome of that. It will have a better power factor as well, so I will be happy with that as well. And I actually need this cheaper, rougher, hotter data center with hot air containment and a concrete floor and everything from the front, everything from the top, in order to unlock all the power and cooling benefits that Open Compute offers me. And that's a bit of a problem because I'm not getting that. In the Uptime Institute market, in the Tier 3 data center market, I have a two-sided market. I have a market where demand and supply are anonymous. People are building data centers without having the name of a customer on the book. But if I am looking for open compute data center space, I probably have to have that built for me. So my name's on the book. That gives me higher latency because it's not pre-built. And my commitment to using that is also longer because it's now built for me and not general data center space. And the part of the data center project within the Open Compute Foundation is important because this common spec that people build and commit data center space to without having a custom name on the book is the key that unlocks pre-built data centers that match the spec, which are necessary for getting big racks in there that are very heavy and which are also key to unlocking the power and cooling benefits that Open Compute has. So one central part of the Open Compute work is basically this data center team. Getting that spec out and getting people to commit to build data center space to that spec and to these conditions in order to actually get the benefits of everything else that you put in there. If you have pre-built data center space, you have it available quickly, you have it available at a higher flexibility, shorter commitment times, and that is the key for smaller business. People like Facebook and Google build data centers multiple at the same time and fill them completely alone. But if you are a smaller customer, if you're smaller than those, then you need that two-sided market for that to take off. That has a bit higher cost, of course, because you're basically paying, when you're paying the rent for the data center, you're paying also part of the risk. If you're our size, you also have capacity fragmentation, because half megawatt rooms are not going to cut it. You need too many of them to actually be fun. But for normal sized companies, that is not a problem. So once that market is there, you're basically just ordering rooms from the market, and they will be available close to immediately, so 3 months or less. That's the thing. So how does this work on smaller scales? How do you make Open Compute available to smaller companies? Part of it is to look at the rack and the room as a system. You have the rack that is able to run in harsh, hot environments that are less nicely decorated and air-conditioned than traditional data centers. And then you build a data center that is cheaper and cools less and does not have all the power conditioning and stuff. So that with the cheaper data center and the cheaper running costs, you can actually leverage the rougher and tougher Open Compute hardware to have less operating cost of the entire thing. But that means that these two things need to be built for each other, and they feed on each other and on the definitions so that they match. And you need that pre-built, you need the two-sided market. And only then, with this, you will then later leverage the documented machine interface for open integration. That means that people like us or others are going to write provisioning systems that manage the entire life cycle of a data center, not individual racks or data center chassis, on a larger scale, to not only utilize it like Kubernetes does it, but also provision it across the years in an automated way. And then you have something that is actually worthwhile and is progress over what we are currently doing. But that requires all the openness and all the specs from the OCP Foundation. That's why we're looking at that. Questions?
What's the max operating power or the temperature? Max operating temperature?
I have been told that these systems will survive 35 or 40 degrees air in. That will then give you 60 degrees air out, and that is why you don't put people in a hot air in an Open Compute data center. Because then you get mummies out, and then you have a lot of paperwork.
One other question, Chris?
It might be worth pointing out that one of the accelerators for the storage disaggregation is the fact that our server fleet only has two 2.5-inch drive bays per server, which is a lot less than in similar hyperscale environments.
Yeah. So one of the accelerators of the disaggregation is that the space for disk drives on the server is limited in blades as well as in these things. But also we find that the storage space that is in the servers we have is also always over-provisioned. Of course, if that is full, the server is not serving properly. And with disaggregated storage, you actually cut the volumes to size, so you have also less overhead. And that enables also a much faster transition to SSD where it's not already complete.
Great.
Thank you.
Thank you very much, Chris. All right, we're down to one more, and then this, the best for last. Oh, Ruth. That was great.
Good evening, everyone. I know I'm keeping you guys from the networking, so I'm going to be fast. But I'm also going to be a little bit more. It's a bit more storytelling rather than anything else. I nearly saved the laptop there. I just want a quick raise of hands of people who are from either from the telco industry or know or interact with telco data centers or telco. So we got 1, 2, 3, more than what I had 2 weeks ago at Data Cloud UK, where I was the only telco guy. So so it's nice to have you guys here. One of the things I have to tell you that OCP for me was just another acronym, right? And I got to know more about OCP from a pragmatic point of view. And what I'm trying to give you is a picture as to why anything open is something that we need to think about, right? So just going to talk about the meetup in Amsterdam. That's I was told for a presentation today, so this is something I put forward. A bit about me, I'm also the outgoing co-chair of the Edge Computing Working Group at TIP, at Facebook TIP that Steve mentioned, which is a sister organization of OCP. I started something called as Take 3 Innovate, which is basically innovation and design, a technology design innovation kind of consulting. Previously I was at Telefonica working at customer-centric networks. And a fun fact about me is I've survived 7 earthquakes. So if one happens here, there's a good chance we'll survive. Amsterdam's not known for them, I know. But it's a fun fact just in case. And I also rolled out some Wi-Fi connectivity for Native American tribes up in North America. So just a bit of a background. And I'm in that bit of a I call this the black hole of unemployability because I'm a mix of all of them. Right, so so let me take you on a journey, right? This is telcos, everybody knows telcos, banks, utilities, we're traditional legacy companies. We have a huge, let's say a huge customer base, but we also move very slowly, and we have a lot of people who are changing that. So let me start. I mentioned something about what I did at Telefonica. So I was working in the innovation department. I was in their innovation department based in Barcelona. And the reason they hired me was for this fancy acronym CCNI, Customer-Centric Network Innovation. The idea behind this is that let's start building some innovation around customers rather than let's just build technology and hope somebody buys it, right? Which is what we've traditionally been doing. And there's a reason why I'm showing you this, because this is quite important. Everybody over here is coming from a data center background or from somewhere where OCP made sense, right? For us, OCP never made sense. Like when I started this, I didn't know what OCP was, and I didn't even know whether it made sense or not, right? And that's why this is really important, because the applications of OCP that you have today, or for any technology you're using today, is not the potential it has in 5 years, right? So all you guys who are selling OCP stuff, you got to be careful, because in 5 years' time, this kind of kit is going to be used for stuff that you don't even have in your radar right now. And I'll give you the example for that, of why that's so. Anyway, so what we did is we went to our customers, our own B2B customers, our B2C customers, and we also went to our own Telefonica, our operations guys, our marketing guys, and said, hey, what's your problem? Like, not like, what's your problem, but hey, give me your pain points. Like, tell me how I can make your life easier, right? And all these guys came up with this. And I really, really urge you guys to do this, because it's pretty much the same for all companies, right? Our own guys were like, hey, we have these old equipment, blah, blah, blah. For example, where our operation guys took, for one of our customers in Australia, took a 3-4-man team, 12 weeks to set up a point-to-point VPN, right? In today's world where I can just go pay, $150 and get it online in a second, right? And that's our core business, right? And that's the problem. So you go and say, hey, why can't you do this? Oh, because I have to get it from Nuash, and then I have to figure out the connectivity, blah, blah, blah. So just trying to figure out the problems. You put them in a little bubble and you say, okay, I'm going to innovate around here, blah, 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 right? And this is quite important. The reason this is quite important is we have to get the ball rolling, right? So we sat down with our team and said, okay, what can we do about this? So we took all these problems, we took it to Telefonica and said, hey, guys, can you guys tell me how we can fix this? And they were like, yeah, we can do it. It's in our strategy. In about 5 years' time, we'll be able to do it, right? It's a very easy path. It was aligned with our architecture. Obviously, 5 years is too long. And then we had this one. Just basically look at edge computing, look at OCP, SDN. Again, these were all like, basically do a search for acronyms for three, and you'll come up with all these cool stuff, NFV, SDN, virtualization. And the benefits of them were quite a lot, but the risks were there was no industrialization, no acceptance, there was unprecedented scale for something like this, because these were things that were still being done in the lab. People are doing POCs, you had beautiful, you could go to a stall at Mobile World Congress and you'd see some demos there. But what we realized was this was more incremental, this was more disruptive, right? And in the end, this is what we did. So we picked this. Now I'm gonna tell you what we did at Telefonica, right? Because I don't want to put it in, I don't want to be too technical about this. But basically what we did was we used fancy new technologies to convert our central offices. Central offices are small telecom exchanges, right? So what you would normally know as an exchange, where somebody would say, hey, your exchange is so far, so that's why your ADSL is so slow, blah, blah, blah. That's our infrastructure, that's what we hold. And what we wanted to do was convert them so that we could provide better services and solve those problems, right? And to put a number to that, it's 800 of them in Spain that we're looking to change. So 800 of these locations were going to become small micro data centers with OCP hardware, provisioning, connectivity, and services to you, right? And that's just in one country. That's 800 out of 3,200 locations that we have, right? And when I mentioned this in the data cloud, all the data center providers were not really sure what I'd said, because 800 is but these are exchanges, and we only serve about 20,000 customers per exchange, right? And there's a slide right at the end which tells you why this is important. So I'm kind of giving you the picture of why we were doing what, and why we picked certain technologies. But coming back to our design principles, I'm coming. This is the important bit over here. Don't worry about this. But when we started doing this, and this is quite important because all of you over here are looking at data centers, or you're looking at equipment in that rack. When our engineer, so when we deployed this first one, we got a call from the engineer from Ireland, and he said there are no servers in the rack. We're like, what do you mean there's no servers in the rack? He said, no, there's no servers because he's a network engineer for one of the 7th largest telco in the world, and he'd never seen open doors and stuff like that. So that's the level of awareness that we have in the telco industry, right? But what we did was we said we were only going to build, for us, we were trying to change the way we were providing connectivity to our customers by solving those problems. So we said, what would we do if we went to North Korea? How would you put a network up in North Korea? And this is a question to you, how would you put up a data center? And suddenly North Korea said, hey, come put up data centers here. So the idea was to try and use the cheapest, the most efficient technologies that we had that were scalable and that were solving problems, right? And that's how we picked the hardware that we picked. That's how we picked the software that we picked. That's how we built the design principles. And you can search for on-life networks online, and there's plenty of Broadband World Forum presentations with more details. But what I'm trying to get at is that what we managed to do was try and figure out why we needed this technology, right? Because everyone who's trying to do a business case for you, Chris, you would know. When you're trying to do a huge transformation, there's always this: where's the money? Show me the money, right? Where's the money going to come from? And in a lot of cases, you're moving to a position where it's not going to come from one optimization or from one use case. So, for example, for us, we never did a business case for this. We just did a business case of the problems. We knew how much the problems were costing us, right? Now, this is an interesting slide. So I think this was a telco slide, but so when people started looking at 3G as a standard, it was designed with voice and MMS for kind of what it was going to be used for, because it was designed 5 years ago. Oh, well, before 5 years before it started being used. It was used for data. 4G was designed for data, but it got used for video. So what we realized was that the next generation of anything we were going to do, and this is true for every kind of industry that you're going to have over here, if you're designing it for something today, it's going to be used for something completely different, right? And this is why what I said earlier, that the applications you see for something like this today are not the applications that they're going to be used for in 5 years' time, for 2 years' time. And I'll show you some statistics that will kind of confirm that. But this is what we have to do. So we have to try and build something, a solution for our customers as a telco, as the 7th largest telco in the world, with 350 million customers. That could be used for anything. That could be used for automated cars, could be used for drones, could be used for advertising, for VR, AR. We don't even know. Nobody knows what VR is. Anybody over here who's seen VR make money? Smart cities, anybody got a smart city that's making money? No, but we're supposed to be doing that, right? One of you is going to come to me and say, hey, where's your network? I'm implementing smart city in Amsterdam and I need network that's IoT and sensor compatible. I'm going to put 1 million sensors in it, and that costs me money, right? 1 million sensors, data for me to move from the sensor to the internet costs money. So I need to design something which can be scaled like that, right? And this is where the challenge comes, and this is why we went for something that was quite scalable. I'm not going into quite a lot of the details of the nitty-gritties of telco design process, but telco design process is quite old as well. We design everything as if the whole world is going to use us, right? And we never get used, right? But Chris, you mentioned something which is quite interesting as well. And again, this goes to like banks, utilities, booking. You mentioned it, but one of the other things we realized was our customers weren't interested in connectivity. My customer didn't care 4G, 5G. He still can't get YouTube in the metro. He doesn't care what XG I'm getting. You go to South Korea, they bundle 40 GB of data on your mobile plan a month, and people still use it up on 20 days. On the 20th, they're still out of 40 GB, right? So you have these problems which, you might say like, hey, you guys should just give more data, just add more data to your plans, right? But these are problems that you can't solve like that. So you have to change the way you're provisioning these services. And then you have to change them and not call them services, you have to call them experiences. Because this is what we've done, right? We've dug up roads and booking, you guys sold hotels, banks take money from the mattress, put it in the account. That was your core commodity business, or you would probably give loans as well. Then we started doing products, which was like we would start bundling them in shops, start selling cool stuff. Now we call them services, VPNs. So I'll give you an example of how inefficiently some of us are doing it. I'm pretty sure that the KPM guys, you guys are doing it really well, but I'm just saying that, just giving from services. But this is where what I call the unicorns are grazing right now. If you look at any unicorn, what are they doing? They're building experiences. They're not building products. You're not building products anymore, you're building an experience, right? I mean, you said it yourself, I didn't have to even show you this slide. But this is quite needed. You need the customization, right? I have clients, gamers in Spain, they pay 195% of the average ARPU, right? They're only less than 3% of the customer base. And for the last 4 years, they've been asking for a low latency gaming product. Saying, hey, I'll pay you 10 euros, just let me get to that PlayStation server really fast, faster than the guy in the UK or the US. We've not managed to do it because it costs us 12 to 16 weeks of just marketing time. Forget building it. Marketing time of customizing a service that we can give to our customers, right? And this is important. And why is that time there? Because we use proprietary equipment. Again, coming from what Chris said, where are we coming from? Proprietary equipment, licensing, processes, right? And so we had to actually change all of this. Sorry? A lot of processes, yes. But we had to change a lot of this. Because if you want to do this customization, I want to add, I don't know, a security service on my infrastructure, right? We managed to do it in a day and a half. We integrated McAfee's security service in a VM, available for 20,000 of our customers, day and a half. So, the moral of the story is, firstly, try and figure out this, but you need to be able to change what you're offering really fast. And I know everybody's like really confused right now, figuring out what the hell was this product? What were you making for it? Like, this is all, but I put this slide in to make you understand. I've got about 5 minutes to show you what we did. But basically, this is what the connectivity space looks like, right? You have some private clouds, you have the public internet, you get the telco guys who charge a lot of money over here, huh? A lot of money for every bit that moves from here to here. You have our network, which is, if you go to South America, is anywhere between 6 and 10 hops long, if not more. You would probably hop to Miami before you would go anywhere else in Latin America. You have the access, and then you have the customer. So what we were doing is putting 800 data centers around here. Right? We did 3 before I left Telefonica, purely because we were that disruptor that was kind of shaking the strategy. But the idea is that we're going to roll out more of these. But the idea is that what we do over here is we put in OCP equipment, we put in open source software, we're working with the CARD project, with TIP, with the idea that now we can we can squeeze these clouds. So imagine if I'm just twisting them and moving them here. So now all of a sudden you have cloud, like an distributed edge cloud available here, which can be running Amazon, McAfee, it can be running the CDNs, it can be running anything that's running in the cloud. But it's 4 milliseconds from my customer. 4 milliseconds. Now that's powerful. The reason that's powerful is because there's no other entity in the world that can have that granularity unless you're going into somebody's house. 2 years ago, I never thought we would be doing this. I didn't even know what OCP was. Right? So it's really important. And the reason we can do this is because we actually stack OCP servers, we have edge core switches, we have OLTs, virtualized OLT, which also are, I think, OCP certified. And all of that just sits in, I think, 2 of those racks and replaces 8 or 9 racks that we currently have in each of these locations. Right? And what's even better for us is the fact that when we started doing this, we were like, hey, it'd be really nice if you could have CDNs, because 70% of video can now be cached, right? And this is really important because video is gonna basically change our industry, it's gonna change everybody's industry over here. So we're gonna start putting video, we're gonna start caching video here, because at the moment, Amazon or Akamai or Netflix have their content here, and it goes, let's say you're watching the Game of Thrones finale. This pipe has to cater for the peak at 4K for every subscriber that we have over here, right? And that's more than, so the average user is about 30% less. So that's an investment of close to 5 million every 2 years just to upgrade that pipe for no benefit of us. We don't even like get money from Netflix. Like we get peering over here a little bit. But if we can now offer Netflix and say, hey Netflix, you know what, when this goes above a certain peak, we can actually squeeze out your CDN and put your CDNs here. That way you're only sending 1 copy of the content here and we distribute it to every 20,000 customer. And I'll tell you what, I'll do this for you if you pay me 10p per you know, whatever, 10% of what you're currently paying us. So those are the kind of business models that are kind of coming out from what we're doing, which makes this kind of an application quite powerful. It also starts something called edge computing, which we can talk about later on. I don't want to bore you guys, but the reason it's important and it's powerful is because the openness of this means that both the hardware and software, just because I'm at OCP doesn't mean I'm trivializing the software element of it. But it also means that we can get Amazon and Azure instances running over here. So your customer has a better experience being 4 milliseconds away. You can do remote, so when you're doing a backup, you can back up from here to here, keep 10% of the most used files over here, and then do a cold backup into Amazon in non-real time. The really cool stuff, our customers, our B2B customers hate this about us, is they have to come to us to buy a business line, and we'll get, hey, 10 megabit, yeah, it's gonna be 1,000 euros. Yeah, but how come your residential is only like 50? Well, because you're a business customer, you know, it'll give you better service. So they have to buy this 1,000 euro line from us, and then they have to go to Amazon and say, hey, Amazon, can I buy your backup service? I'm gonna say, yeah, go and buy it from your telco. The telco will sell it, make a markup. But in the end, the customer still has to jump through these hoops. He has to have an IT guy there. So what we've managed to, and this we've just demonstrated, we haven't actually put into production yet, but the idea we had was like, hey, can we, because now we can actually initiate, because everything is virtualized from here, we can actually initiate a connectivity from here on demand. So the moment the customer presses backup at 5:32 p.m. after the bank is shut, we can initiate a 1 gigabit per second line for 8.5 minutes. He does the backup, and the line goes down to 1 megabit, and that's what he needs to do his whatever SAP crap he's doing most of the time, right? And that's the first time you can do that, because that thing, what you guys think is storage and compute, for me is connectivity at the edge. I can now provision fiber on demand at the edge, and I can also load services on it. So I can actually run not only CDNs, but also security services, advertising content, everything at the edge, which I don't think anybody's using this for at the moment, over here. So, and you said free, but are you even using this? Yes, we have a beta on currently in Madrid. You are more than welcome to go and meet my ex-colleagues. They will show you around, show you the data center. They will actually show you the beta. And if you happen to live in that neighborhood, you can sign up for it as well. All right? But also what it lets you do, this openness, right? So we currently use GPON. GPONs are 2.5 gig per port. Celestica GPONs are 2.5 gig per port, which basically means that we have 2.5 gig, the 2.5 gig gets split, and then it goes to our customers. This year, we actually have the XGS PON, which is 10 gigabit per port, being tested as well. And we'll have the T-PON, which is 40 gigabit per second, being tested as well. So that's 3 generations of fiber, 2.5, 10, and 40. So that's what? 10, 20, nearly 15, 18x change in bandwidth, operating simultaneously. Just because this thing can run any software. We're managing all the different technologies with different VMs, with different management software, and then they just work in parallel, right? And the next slide, this is really cool. Do you see this? Do you see the average age of every technology that we rolled out? It's halved. And the reason this is important, because you could spend like, I don't know, you could go to CFO and say, hey, sign me a check for 10 billion, and in 16 years, we'll be rolling in money. Can you sign me 5 billion? And in 8 years, we'll be rolling in money. Okay, now 4 years. 2.5 years. So now you're gonna go to your CFO and say, hey, you know what? We need this like huge rollout for 5G, but we'll probably be relevant for about 2 years if you're lucky. You can't, because now the technology is moving so fast, everything is becoming software. And you guys know this. I'm kind of talking to the converted over here. But the world that I come from, we still talk of a PO. So when I do this presentation of what we did in Telefonica, the guy said, yeah, but where's the business case? Why do you need a business case? Because when I go to my CFO, he needs to know the business case before he signs off. And my question is, do you think Facebook or Google have to go sign off from a CFO if they have to put a new feature on their product, which is either advertising or timeline? And if the answer is yes, then okay, go ahead, think that way. But mostly the answer is no. And the reason I say that is because this is super important for what we're doing over here, because now, I mentioned to you, we could create new products, we could create new services on demand for our customers in a matter of days. Which means if tomorrow my customer says, hey, I want to do crypto mining, can you, well, so nobody knows this, but we started working on machine learning and AI because that was becoming big. So we're working with Intel to see how we can get FPGA based cards very specific to telco workloads. Because what we try to use is machine learning to basically do a lot of SON to like make sure our antennas are all fine and stuff like that. And that's very sensitive to latency, right? So that 4 millisecond really helps. And also not pushing stuff into the cloud. But anyway, I'm sorry I've taken up a lot of your time. I've got like 2 minutes. Oh, I've got 5 minutes to 3 minutes. All right. Sorry. So in the end, I'll tell you what happened. Our project's currently going ahead. It's in beta stage. We did have a business case of a few $100 million savings over a particular set of years. I can't give you the numbers, or it's 3 years, but I can't give you the number, but it's a few $100 million. A majority of the savings was coming from the fact that a lot of this equipment was replacing very specific equipment. So we have like Cisco routers. So I mentioned here, like I said, Netflix data comes in from here. It's like 40x the time of the amount of data that's going from here into Netflix. So we tell Netflix, hey, pay us some money because we're taking all this data from you, right? And it's called peering money. Hold on, I lost my chain of thought. Sorry? Yes. So we have these Cisco boxes over here that count. Over here, we count every bit that goes through to Netflix or to Facebook, and all it does is counts. Right? It's like a guy on minimum wage that's just counting people going. It costs $500,000 a pop. Right? $500,000 a pop. So we just replace it with the function. So it's $500,000 off at least 100 sites. Right? And then now you say, well, what else? Well, the opportunities become endless. The advertising. If you were at the Brand World Forum, this is my last example, Steve. I showed in a particular set of slides. I don't think I have them here. But the biggest newspaper in Spain, it took 23 seconds for the ad to load, for an advertising, for a banner ad to load, 23 seconds, and they varied between 8, 15, 12, depending on the ad. But the most was 23 seconds, right? But that's 23 seconds for a banner ad. The auction is still done in 300 milliseconds. The newspaper still gets its money because it's sold the space. The advertising agency gets its money because according to them, they've got eyeballs on that ad. Who loses out? Pepsi, Nike, Adidas, name a brand, the guys who are making the ad. And I would say, hey, is 23 seconds a problem? No, it's not, because we're living with it, right? We all are fine with it, because for us, we just scroll up and like, who wants to look at an ad? Nobody, except for booking. Your ads are pretty fast. But the problem is when these ads come now, it's like a 73 kilobit or kilobyte banner ad that's taking 23 seconds to load. If you went to Facebook or Oculus or Booking and said, hey, how is your experience going to be in virtual reality? And you'll be like, well, I'm still going to be serving up that 73 kilobyte banner ad and it's still going to take me 23 seconds. That's where your problem is, right? So there are all these industries that are taken for granted now, but my experience of virtual reality has to be, I walk into a bar and somebody pours me a Heineken, right? Because I like Heineken. But if you go in, you like Desperado or whatever, but that is very contextual, and that needs a lot of low latency compute, storage, contextual stuff happening over here. Okay, that's my time. So, bottom line, open source is good. It's only good because you don't know where your business is going to be in 5 years' time. And if you have any questions about what I did, oh, actually, I do have these slides. These are the slides that showed you the 3 seconds kind of the load up time and stuff like that. Anyway, if you guys want to come talk to me about any application about this kind of stuff, let me know. But I want to thank OCP and Booking for having me. And that's it. Come speak to me. Thank you.
All right, I think that wraps up the day. I hope you guys found it valuable. We tried to make this less vendor-led and more interactive and more technology-focused. On behalf of the entire team at OCP, Bill, Archna, and myself, thanks to all the speakers, Thanks to everyone that provided demo gear, and most importantly, thank you, Booking.com. You guys are fantastic hosts, and really appreciate all the hospitality. And I need your coaching on the drinks. Where do we go?
The most important part of the night.
He started with that.
This is not a bait and switch. I think we do have drinks.
For anyone who's joining us for drinks, we're going to be at Kabaja's. I think it's pronounced Kabaja's. It's downstairs. It's around the corner by Starbucks. If we could get about half the group to go out this door and head out through the lunchroom, there'll be somebody there meeting you at the elevators. I'll take the other half of the group this way, down the stairs, and or down the elevator. And, see you there.